Okay, so we're looking at this question. Given that log with base 3 of x equals to 2, determine the value of x. This question is simply to use the definition of a log, so there's actually no working out to do. Remembering this basic idea, log with base a of b is equal to x simply means that b is equal to a to the x. So in this question, good, x is equal to, if 3 goes up, 3 to the power of 2, which is 9. Okay. So very straightforward for question A. Part B. Calculate the value of y for which 2 log with base 3 of y minus log with base 3 of y plus 4 is equal to 2. Now, good. So if we use the power rule, so let's start with that. Log with base 3 of y squared, because the 2's gone up, minus log with base 3 of y plus 4 is equal to 2. Okay, so that's the power rule. And now we have here subtraction between the two logs. So we therefore know that that becomes y squared over y plus 4 has to equal to 2. We look at the first question. We are in exactly the same situation of log with base 3 of x equals to 2. What do we do? They're hinting, okay? But when you get to a situation where you've got log with base of something is equal to a number, it's very straightforward. This, if you like, replaces the x in this part here, okay? So you can see your x there is now y squared over y plus 4. We know, again, from the laws of logs, that y squared over y plus 4 must equal to 3 to the power of 2. We did that in part A. That equals to 9. And from here, we can see a very straightforward quadratic equation that needs to be solved. So y squared is equal to 9y plus 4. Multiplying everything out and taking it to the left-hand side, y squared minus 9y minus 36 equals to 0. And here we have a very straightforward quadratic to factorize. Y minus 12, y plus 3 equals to 0. Therefore, y is equal to 12, or y is equal to minus 3. So that's part B done. Okay, so let's have a look at part C. Calculate the values of z for which log of base 3 of z is equal to 4 log with base z of 3. Now, I'm just going to go back to, this is not the word for it, but I like to call it, it's the special case of the change of base formula, so I'm just going to remind you of that. So when I have this situation and I want to change it to another base, again, because the b is on top, if you like, it's positioned higher up than the a, I remember that as the top part of the fraction after the change of base. So I'm changing it to some other base c, and b is the top part of my fraction. Again, it's c that I'm changing my base to, and a is the bottom part of my fraction. Okay, so it's easy to remember if you look at it like that. And if I wanted to swap the a for a b, okay, we can make up a name. Let's call it the swap, the base formula. Then it's a special case where c is equal to b, and we know that in that case, log with base b of b is just 1. So in other words, if I'm going to swap the base, it's just 1 over. Okay, you can see that the a and the b has swapped over, and it's 1 over. And we're going to use that property, okay, to answer question C. So here, the base is 3. Here, the base is Z. Can't do anything about it until we swap over. So on the right-hand side, that is equal to 4. If I swap it over, it's going to be 1 over log with base 3 of Z. Okay? And that is equal to log with base 3 of Z on the right-hand side. Now I can apply the usual rule. I have a fraction if I take this over, then I multiply. So what I'm left with is log with base 3 of Z. Now I have to be careful here, because when I multiply, I'm timesing something by itself, so I just square the whole thing. That's important, okay? I'm squaring the whole thing. And that is equal to 4. And a common mistake, I suppose, would be to say, okay, that's log with base 3 of Z squared, just the Z part, like that. That would be the mistake. Okay, so I'm just multiplying, like I'm multiplying anything else. When I times something by itself, I'm squaring it. Okay, so I just write, okay, log with base 3 of Z all squared is equal to 4. Now I can't find Z until I get rid of this 2. Now, log with base 3 of Z is equal to plus or minus 2. I square root the 4. So therefore, Z is equal to, again, we go back to our definition of a log, 3 to the power of 2, which is 9, or 3 to the power of minus 2, which is 1 over 9.